Dum 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 da da dum do dee dee boom. Yes, yes. Last time we made a lot of progress. We know we can make the USB controller with Arduino. We have the encoder and it sends also control messages when it turns, which is all I needed to know. That was my first question. If that's possible, and yes, it is possible. The rest is easy. Just a couple of buttons which will send like short keys, right? Is there something like long key? Let's get to it. Let's get to it. So to be honest, I'm actually excited about this part because I really like designing things. Dum 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 dum. And the whole time I will be playing this. Dum dum. Punishment. Let's slice this guy. This is the first time ever I'm using Cura because I learned on internet about this new feature which I'm going to try out. And let's start printing and I can go sleep and we will see tomorrow. Ta-da! And the printing is done. Finally. Boom! It says 19 hours there, and yes, it was printing for 19 hours. I'm not reprinting this if things do not fit. I'm just going to cut into it or glue it or whatever. All looks pretty good, and this was the first time ever I used Cura. It was because of this fuzzy skin. It did a very good job, except I don't know what is this. Do you see the line here? It kind of started from here. I think that's where Cura completely messed up. It is an experimental feature, so yeah, I guess why. But I really like the surface. This is great. You can see the settings for the fuzzy skin, which is thickness was 0.3 millimeters and fuzzy skin density was 5. So that's how it looks like, and yeah, it looks really good. So my Arduino will go into this little PCB. It has some labels, but these are for different, obviously for something longer, but that's really nice. So I will put this guy here, and yeah, it needs a little sanding to fit it there, and it should kind of snap there.
The USB should be visible from the inside. So that should be done, but this is easy to fix. There is a little tolerance issue. My encoder will go here. I'll look for something which I can put on the top as a screw. And the last part, I didn't try this. This is the first time I'm trying it. So these buttons should fit here. Yeah, they almost fit, I'd say, if I push them hard enough. And that's why there are these little notches here. The key switches should latch on them. This one I decided to go 90 degrees, so they should go here. This guy, I believe it kind of should fit here, something like that. I need glasses. This might need a little sanding as well. I don't like this ugly black thing, so I was thinking maybe I should paint it gray. But then I decided I have a gray filament. Why don't I just create a little mask which could just go on top of it with an opening for the buttons and opening for the knob. So I did fit the PCB there. It's nice as I imagine it would be. I found a little nut for this guy, and yes, I fitted the stabilizers. So if this button gets stuck, it's because of the stabilizers. Well, it does click. It's the first button. Would that be good? Yeah. Well, I will see about this guy. To be decided later. That's all what it is. Oh, and I have to make a knob. The original has so many buttons, but I actually don't like controllers which have too many buttons because that's just basically a keyboard. So I'm printing the bottom. Let's see. That would be the bottom. Encoder. When you turn it, it makes this sound. Vroom, vroom, vroom. Can you hear it? It's called Detent or Detent or something. Most encoders you can buy are like this. Have the detent. So they don't turn really by themselves. Which is okay, except in my case, for the video editor, I would prefer one which turns smoothly and preferably almost by itself, so I can just like swing the little wheel and it will turn by itself. Now surely you can buy one without these detents, but I'm not even sure if they can turn easily or if they will have some resistance. Probably they will. Let's see if we can somehow adjust this one to remove the detents. Okay, so I found a video which talks about how to remove the detent from the encoder. Basically open it and then kind of like fish it out. I used to have a Hakko iron, but I wasn't using it at all. So I sold it to a girl who bought it for her father. And I was like so impressed by that. I never got soldering iron from my kids. I don't even know. I don't even see if I'm actually soldering it or just pretending. Well, we'll find out soon enough. It's too close. I have two glasses. I have meta glasses to take the video and reading glasses. I'm not pleased by this at all. Now everything goes to ground, so every single switch will have a ground. So I'm just going to connect everything. Okay, another day, and look what I've got. So two things. I have two things with my project. The first thing is I finished soldering this. So yeah, a lot of wires. I did not test a single thing, so I don't know. This will be the test now. And the second thing is the bottom plate finished. I made this thing exactly the size of the opening here. So of course it didn't fit, but I had to sand it a little bit. It's a rookie mistake. And I know about that because I already made something like this previously, which is the tolerance test, right? This peg is 10 millimeters diameter and the hole is 10.2. It still cannot turn. You have to like force it with a hammer. So anyway, now I sand it and it sits there fine. So that's what it is. And now I'm going to test it. So I need to run a couple of tests. First of all, my encoder still works. And second, if all the buttons still works. Sometimes I feel like if I overheat the little leg, that might damage the button inside. So, but I have plenty of buttons. Let me plug it in. Hopefully it didn't destroy everything. So yeah, encoder is fine. Didn't mess up stuff there. Now let's test each button. Okay. So this should be, yeah, it's boom, boom. This is fine. And this is fine. So number 4. So everything works without me needing to replace anything. I didn't make any mistakes. So now I can actually program the whole thing. Excellent, 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 excellent. We are getting there. Just need to design the knob. This library I'm using is actually pretty cool because it has many handlers for different operations. For example, click, double click, triple click, but also long hold. So this could be used many different ways, but I also don't want to make it complicated because one thing I hate is just to remember double clicks and triple clicks. I will be very careful with this, but some functions, for example, undo could be just click and redo could be click and long hold. That feels natural. This glass has been through something here. It just came from Amazon. How nice it is. No more glue stick for me, I guess. To celebrate my new 3D printer bed, I printed a posh version of my old tolerance check. And the second one is when I have a real object, not 3D printed object. This is from a sewing machine. Don't know from exactly where I've got it, but this is 6 millimeter and this is 12 millimeter diameter. So I made little holes, but this time from 12 to 12.3. So 12.3, that's basically completely loose. 12 exact. It could go in, but I would have to use the hammer and it will be the last thing. And all in between, if I want something like easy to turn, 12.2 would be great. And if I want a tight fit, it would be 6.15, 6.1. And incidentally, this thing is 6 millimeters as well. I can really test it here, 6.15. Another thing is, so this is the textured bed. It looks like this. and compare it to my glass. This was on the glass with the glue stick, and you can see the glue stick imprint. So let's go designing. Okay, so here we are after another 2 hours or so. There is the knob. I sprayed a little acrylic on top just to keep it from becoming ugly PLA after a while. And it has nice weight. Also, of course, if you look at the knob, it has this notch here and then it doesn't. And I kind of forgot about this part. I made the notch all the way through. But luckily I have 6mm drill bit, so I just drilled a little hole. It's still a little wet. Hopefully the tolerances are good this time. Okay, so we'll see. This should fit there. Yeah, I think we're going through it. And I'm glad it is heavy. Nice. I'm already printing the faceplate, which I hope, again, I measure everything correctly. But I can just start programming now. I just need to create a couple of buttons in the program and program them as I want them. It should be very easy. Well, I do like this. Professional, right? Whee! Perfect! Ta-da! My new 3D print. I'm just kidding. This is my morning coffee. There! And the reason why it has bandages, it's not because it's sick. It's because I glued the top mask, which I printed during the night. Okay, I just used E6000 or whatever glue I had. It doesn't need to be too strong anyway. It's just a top plate. Pretty excited though, because I think it looks really good. It's amazing what you can do these days at home. Ta-da! Here it is. So I think it looks really decent. Yep. Honestly, I do love the texture. It looks like far less cheap plastic than usually. And the sides are very nice. And the back It's a cheap plastic. So I did a good job, you know. The hidden parts are crappy. I actually realized I'd like to know when this thing is on and when it's off. So I want to add a light, and I will do it this way, just not to have a sticking LEDs. I drill a hole here. This would allow me to add two different colors of LEDs there, perhaps, and it wouldn't look that stupid to have a poking LEDs. I want to put it completely flush with that. This is a little window. I still have those analog inputs, and I think they could be turned into outputs too. So I can just put some LEDs here next to it, or just glue it on top of the little window. Yeah, that's it. That's a quick mod before I start doing anything else. I didn't want to completely ruin the nice face of this guy. Yeah, that looks quite nice. I have two LEDs, they already have resistors inside. So I'll just put a little blob of glue. Another finger.